Hi, and welcome to Talking Wildfire Australia. Today we're here talking with Rhys from Tasmania, and we're talking about technology advances that Tasmania is working on. You may not know it, but there's a lot of interesting studies being done there. And Rhys, can you tell us a little bit about some things that are being worked on there?
Yeah, sure, Michael. So we're working on some satellite detection technologies. We're working on some fantastic communication improvements from the field back to command and the IMTs, and then also hotspot detection, mapping, and different apps that are eliminating the delay and the poor information transfer from the field through to the IMTs. So I'll start us off with satellite detection. We're using two different types of satellite detection, medium orbit or low orbit technologies. These are within approximately a 10-meter accuracy at this time. We still get a few hits that are not real, which we always check them in the field, but it's got a very good success rate and a high level of accuracy at the moment. When there is a heat signature detected by these satellites, an email is sent to our statewide duty officer. The duty officer can then deploy us, and with that he or she will send both the location and also a map. We're using the Fire Mapper technology developed by a gentleman in New South Wales who worked with the RFS or in the RFS. That comes with it. We've pre-populated a generic map which shows us fire-sensitive vegetation, certainly assets or threatened communities. We've got water points, road networks, power lines, all that sort of infrastructure that we historically would have to run around and try and map out and find. That's immediately given to us. We've got a database called List, which stores all that information statewide, which we can access in the field. Going to find that hotspot or that fire, there's two different ways we do that. One is with our aircraft. So we've got a constantly increased fleet of aircraft, and we've got one aircraft we call the SIG aircraft, Specialist Intelligence Gathering. That is a B-3 Squirrel with a very large camera on the front, developed in the Gulf War. It's a large infrared and high level of accuracy when zooming camera. We go out in that. I've occasionally worked in that machine, and we will look at the fire. It can see through smoke, can see through canopy, map the fire edge, map the size, etc. And that sends a live feed directly back to the IMT or the duty officers, or firefighters on the ground can log in on their smartphone and get a real-time, accurate bird's eye view of exactly what the fire is. Distances to impact, rate of spread, all that can be calculated in the machine. So that information is sent through both to the boots on the ground and command, and that enables triage, obviously, if we have multiple events. The other apps, so the firefighters on the ground, they're obviously still moving to that location. We deploy on High Fire Danger, we have rapid attack crews or winch attack crews that are usually with an aircraft, and they can be dropping in to that fire. They will do a size up in the air, and given they've got reception, which they generally can if they fly high enough, they will send through our SITREP, which can be updating that same map, Fire Mapper, with photos, and we can draw boundaries, movements, etc. on that map, which is then shared with everyone. So again, you've got that fantastic live situational awareness. And we can put photos and geo-reference points in that map, which becomes really handy for asset defense as well. Moving forward, we've got lots of navigational apps that we're using as well. Moving forward, we then go into boots on the ground. You can often lose phone reception, especially in most of the parts we work in Tasmania, they're remote. So we've got a new digital radio network, which has been designed to cover most areas in Tasmania, all except the deepest, darkest holes. And that digital radio can then send information as we standardly would, but it's with much higher clarity. And it also has a function that you can put in a phone call back to duty officer or command. So you can have that phone conversation, and that creates a much more accurate description or size up of the fire versus, all the radio chatter. So that's really handy. And the other thing it has is live tracking on the radios. So the command can see exactly where the firefighters are. And if you're in command on the ground, you can see where your firefighters are to ensure their safety, which is critical in that first attack. Other technologies we're using, we've got Command Trailer, which we set up at our forward operating base, which is near the fireground. That's got Starlink connectivity. It's got Wi-Fi boosters and cell phone boosters if there is any reception there. That's independently powered by lithium batteries, a large bank, a large array of solar, and also a backup diesel generator set. It's got touchscreen TVs on both sides, and using those same apps we're talking about, you can draw in boundaries live, and again it creates that common operating platform live to everyone involved, from the firefighter on the ground through to the IMT. Firefighters can double back to that trailer if they need to download maps or share critical information at any time. And hopefully in the future we'll have a sort of bubble over the fireground by aircraft platform that are often already there performing an air attack role, but potentially that could be somewhere that drones start to be used in. And that provides a live map. It's going to be critical for firefighter safety, but also, again, eliminates those confusing communication and inefficient resourcing that happens when comms break down in the field, which is constant in a remote area for us. The other thing we've got is what we're calling our recce cameras, remote cameras, which we drop in sling load via helicopter, and we can drop them on the top of a mountain or on a problem area on a fire edge. They have a camera system that scans the fire. We've got a sync set to every 10 minutes at this time. That's also got its own independent power system and solar array, and it's got a Starlink mesh as well. So that takes a photo every 10 minutes, and then it takes a photo the next 10 minutes, and there's an AI program that determines whether there might be a change in the environment, aka a smoke signal. And if it sees smoke, it'll send an email back to that duty officer, tell them there's something not right, and then the duty officer can actually remotely log into those cameras, control the camera, zoom in on an area, and determine whether a response is required. They've also been setting those same cameras up on our fire towers, which is across mostly sustainable timbers Tasmania land, on mountaintops, classical historical fire towers that were manned in the fire season. They obviously would rely on radio communications and triangulating between towers. We now do that with a camera. Same principle, it scans every 5-10 minutes. If it sees an anomaly on the horizon, it will send an email, and we can then zoom in and triangulate between other towers which are AI based. So it's pretty amazing how quickly that technology is moving forwards. The drones is somewhere else that we're starting to play with. We've got incendiary-based drones dropping the ping pong balls, etc., across for planned burn or wildfire backburn ignitions. We do have drones with infrared cameras, and we're just starting to see the development of bomber drones. And the other one is like a skid steer style mounted tracked vehicle drone. And I really see some great future technology there that we currently turn up. We often will call an earth moving equipment a bulldozer, a truck, and we'll move in behind the bulldozer. Well, a drone could potentially do that in the initial attack. It could do that in a hotter area, which we may not be comfortable in direct attack. And all we have to do is keep the water up, and that can cut a line for access and control as well as suppressing at the same time. Maybe we could even have aerial drones that are topping up that vehicle, much that we see with the Nodwells in Canada, which are topped up by aircraft at the moment. And a platform drone we talked about before, providing a communication base, but also a live mapping update of that fire movement with an infrared camera that can see through smoke. And that's something that we can't do with aircraft at the moment. We can't see through smoke except for the infrared cameras. We've got a few issues to work through with line of sight use on the fireground. Our aircraft CASA, Aircraft Management Authority in Australia, for very good reason, is concerned that if we don't have line of sight of a drone, it can be quite dangerous for other aircraft. And how do we manage other aircraft on the fireground? They're good questions we need to work through. But yeah, the future looks very, very exciting, and it's rapidly moving, Michael.
Rhys, I have a question for you. Could you go a little bit in deeper with the bomber drone or the tanker drone? What use could you see that, and how would you see that integrating on the fireground? And for the research and development teams working on that concept, is there anything you could suggest to them about what could be a positive thing? Because I know that's an idea in the U.S. right now that's got a lot of pushback on it, but I see the concept and I can see the value in it, and I see that you do too. But could you tell us your perspective?
Sure. I suppose there's two answers to that question. The first is direct attack. So a bomber drone could go into smoke so thick that we couldn't operate in there. We couldn't breathe. We couldn't see. They could bomb out spot fires on the opposite side of a control line, for example, in really thick, nasty conditions, and that could hold a fire. Certainly direct attack, if it's a small fire, the drone can go out initially. That could be launched off a vehicle-based platform or truck or from a base. And that doesn't necessarily have to extinguish the spot fire. It just has to keep a lid on it, which gives us the time we need to get there, drop in, whether it's winch or vehicle-based, and contain that fire. And that's basically what we're doing with aircraft, manned aircraft at the moment. Aircraft will never put out a fire by themselves. They need boots on the ground. Drones will be the same, in my opinion. But if they could get there and start a bombing cycle and buy us the time to reach that and contain that fire, that would be fantastic. And the other one is, for the bomber drones, is the water supply, which I spoke of. Any remote area firefighter knows they can do a lot more work on a hose lay with an unlimited water source than by a truck. Often in Australia particularly, we have a long turnaround to a water source. It can be hours. We're pretty lucky in Tasmania, but mainland of Australia, it can be 4 hours from a water source. So if there is close by water, or if we can set up a close by water source with a truck to fill, for example, a buoy wall or a large dam, that bomber drone can allow the troops on the front to continue the firefighting effort by continually providing a water source, whether that's filling a buoy wall in the field from somewhere where a truck or a water tender can get to, or whether it's providing that into a hopper on a vehicle-based piece of appliance. That's fine, but either way, keeping that water source up is one of the biggest challenges we have in bush firefighting in Australia and the whole world. So if the drones can provide that link, it would make us far more efficient, far more efficient. And you could have a smaller amount of people doing a lot more work if they're just working along one edge with a constant water source.
That's great. Thanks for sharing that. I'm sure a lot of people will be interested in it. Can you tell us about some more technology experiments that you guys are working on down there?
Yeah, sure. We're developing, even in our day-to-day work, we're moving to a digital platform. So things like Microsoft To Do is a really good platform for even just workplace management. So instead of the whiteboard and the chalkboard and you're drawing up tasks and lists, that's all in a live digital platform, and the whole crew can see that. That can relate onto a fireground where you might have a series of work tasks or orders, logistical orders as well, and that can all be live and based, and everyone can input into that and see it at the same time. So you've got that, again, common operating platform. So just simple apps that run on every smartphone can make our life a lot better. We're also moving towards, we've been doing smart PDFs for our gear checklists, both in the field and back at base. So, for example, a vehicle checklist, we used to have clipboards and we'd go through and make sure there were 2 Racos and this many branches, but that's all a digitized system now. When that's completed, that can be emailed directly to a soup or whoever needs to in a database, and you can track trends. We're using a lot of hose lately. Why is that? Have we changed brand, for example? And we're trying to develop an app which is going to replace, most organisations have a firefighting pocketbook, which had all that critical information particularly for people learning about weather and fire slopes and behaviour. That's all moving into a digital platform. New South Wales has a pretty good app at the moment. We're building our own, and we're also building in the fuel assessment tools into that. That hasn't been done in Australia yet. So yeah, that's been really handy in the field to measure how much fuel is in an area, feed that in directly to the IMT, but also a statewide database. So if enough fuel has been mapped over, say, 5 or 10 years statewide, when you get a fire in a specific area, you're not guessing on the fuel load and therefore the intensity and the rate of spread. You can pull up a database, see that information was recorded, a number of years ago, and then pump that into your modelling tools. And that'll tell you what's going on in the field, particularly for that initial attack. And for burn planning, that obviously feeds in critical data for our intensity score, our weather prescriptions, crown scorch, all that sort of thing. So technologies are starting to creep in everywhere. Our chainsaws have computers in them at the moment. Our vehicles certainly do. The vehicle operator has 13 computers in at the moment, which can be very annoying, but it is also fantastic the way it's moving. And I think if we harness that technology, we can be far more efficient and far more effective in fighting what is a changing climate. And we just have to keep changing with it, in my opinion. I also forgot to mention, Michael, with initial attack, we're just in the trial stages, but the idea is that we can send out a drone with that first rapid attack crew, and they can launch the drone and find the safest and most efficient way into the fire. Often getting that initial situational awareness is quite difficult from the ground, particularly if an aircraft is not available. So being able to launch a drone, probably from a vehicle, map the area, find the fire, find where it's safe and most efficient to go in, and then land the drone again would be fantastic. We've used them for post-fire mapping and fire intensity classification after fires and burns as well. But generally we'll ground them once the rotary wings come in. But it is managed between the drone pilots and the airbase manager or air attack supervisor on the fire ground. They can fly in the same column if they're separated, but generally they'll work separately.
Around the world, there's issues now with staffing and working in wildfire. In Tasmania, what's happening to address the staffing issues that you guys may be facing?
So like the rest of the world, Tasmania has certainly had issues in retaining staff in the firefighting industry. Half of our workforce, so the organisation I work for now, is seasonal. And obviously that is very difficult in this day and age to support a long-term career because that's what the banks want, full-time job and certainly other community and relationship pressures. The pay bracket with the cost of living, people are finding it very difficult to justify, particularly if we have a quiet fire season. The industry is set up around the world, I believe, in having an overtime basis. So if we don't get fires and people don't get overtime, it's a huge amount of their wage they don't get, which often makes the wage acceptable because it is at quite a low entry. So we're working on negotiations for pay increases, negotiations for better working conditions, and negotiations in investing in our people in training, and looking at what training can be applicable across multiple industries as well, so people feel more comfortable and empowered in building a career inside bush firefighting that they can fall back on in later years of their life. But it's certainly an issue here. The positives to a turnover in our workforce have been a new generation coming through that are very tech savvy. They generally are here for the adventure. They love the bush and conservation, and they're ready for change, and they're adapting with our rapidly adapting climate and technologies, which we're discussing here today. So that's been wonderful to have some really interested people that are thinking outside the box in this space, and I've really enjoyed working with them this season. Seasonal firefighting in the eyes of a bank or community or family is becoming very difficult to justify for a lot of people, especially with a low salary. But what we are seeing is the new generation is much smarter, and they're adopting these technologies we're talking about. So it does have some real benefits with new staff coming in. So certainly retention is something that we want to build on. And we're seeing with a smaller number of more efficient, highly tech-savvy firefighters, they can be far more efficient than the historical bulk amounts of labour on a fireground. And that matches in with our rapid and heavy weight of attack on firefighting in 2023, certainly in Tasmania. So a smaller, more experienced, highly skilled workforce can actually be more efficient for a lot of these fires than a large, highly untrained labour force. And that's something that we're seeing develop, not through planning, but just through the pressures of the world and new technology combining with that. But there is no golden bullet, of course. But yeah, better training, better remuneration and better conditions is something that I think internationally we need to recognise, along with physical and mental health support networks for our firefighters.
Around the world, there's many people that are really interested in wildland fires or bushfires and the researching aids to help us become more efficient in our jobs. Is there any technology that you could see a value in that you would recommend that it be worked on in the future?
I've been brainstorming about combining all the technologies we're talking here today with our first attack. So some military applications have a small insertion pod, which is slung load in into the field and deployed with humans inside of it. That could be combined with a similar tech that we're talking about with our forward operating base. So it's got radio networks, computer networks, mapping, a satellite link, first aid, food, water, and firefighting equipment, which is basically what we're doing at the moment, but it's all piecemeal. If we could deploy this pod system with a small bunch of firefighters, similar to the smoke jumper model or our winch attack models, directly into a fire, get around that fire quickly, provide excellent information to command and other support networks, and that would provide us an excellent base to work from in the field. I figure that could be something really cool. Obviously, it comes with its hazards. Live sling loading is dangerous. But yeah, we're just combining all the different technologies. So that's something I've sort of been interested in. I know they use it in special forces in limited situations. We can sling trailers. We've got remote boxes that we drop into the field as well with gear, but we haven't combined those technologies. So battery banks, solar panels, radio systems, radio repeaters is another big one, and the satellite link back to base. So yeah, within the next few years, hopefully we'll see a combination of all these elements to make firefighters safe and as efficient as they can be on the ground, and the IMTs as efficient as they can be with accurate information.
Riz, if there was someone around the world that had technology that they were working on and they would like to trial it in the wildfire world, especially somewhere like Tasmania that's smaller with a test bed, how could they approach your organizations, or what would be the best step for them? What could you recommend?
Sure. Yeah, I'm happy to have any conversation. Having these conversations is really critical we've got a very small industry, particularly in Tasmania. So yeah, happy if anyone wants to reach out, and I can certainly put them in contact with the appropriate people. There's certainly an appetite for new technologies in Tasmania. We have to be as efficient as possible because we are a small firefighting agency or force, and there is we're happy to change. We have to change with climate change and new technologies. So yeah, happy to have any discussions.
Sounds good. Well, thank you for your time today and sharing this with us. We all really appreciate it. And again, thank you very much.
Thank you very much, Michael. Cheers.
We're doing this for all of you. If you like what we're doing, please give us a thumbs up, hit the subscribe button, and leave a comment below. See you next time.